Hello and welcome to Ushering Success. Today we'll discuss one of the toughest integrals in IIT Jam 2020. As you can see, this is a double integral which is differentiable in the domain of dy and dx, and we have to first find out the value of the integral dy, which we will call as I1. This is integral 0 to root over 2x minus x square root over x square plus y square dy. Now notice that here only y is the variable and x is a constant. So we have to first understand the nature of this curve. So if I draw this curve as a function of y, then this would be x root over x square plus y square, and for y is equal to 0 this becomes x, and subsequently for increasing values of y the curve will go like this. So at y equal to root over 2x minus x square, this curve will attain a value of root 2x. So we can see that it is a positive integral lying in the first quadrant. So we will integrate this using the rule of integration by parts. So we take root over x square plus y square as the differentiable function and dy as the integrable function. So then this integral would reduce to 0 to root over 2x minus x square of y root over x square plus y square minus integral 0 to root over 2x minus x square y 1 by 2 root over x square plus y square into 2y dy. Now all we have to do here is to take the values of 2x minus x root over 2x minus x square and 0 and substitute in this function. We have already integrated it, so this becomes root over 2x into root over 2x minus x square minus integral of 0 to root over 2x minus x square, 2 cancels out, y square over root over x square plus y square dy. Now we can reduce this to root over 2x into root over 2x minus x square minus integral 0 to root over 2x minus x square y square plus x square minus x square over root over of x square plus y square dy. So this reduces to root 2. We have 1 root x here and we can bring 1 root x out of this bracket. So root 2x into root over 2 minus x minus integral of 0 to root over 2x minus x square. I take the first two values, x square plus y square, and that divided by root over x square plus y square will give me root over x square plus y square dy, and then I have a minus here, so minus and minus becomes plus, so plus integral 0 to root over 2x minus x square into x square dy by root over x square plus y square. Now notice that this integral is the same as integral I1. this integral is the same as I1. So therefore I can write this as root over 2x into root over 2 minus x minus I1 plus integral 0 to root over 2x minus x square into x square dy by root over x square plus y square. So I get 2I1 is equal to root 2 x into root over 2 minus x plus integral of 0 to root over 2x minus x square into x square dy by root over x square plus y square. Now if I now we have to consider x as a constant here because y is the variable in this. So x square becomes a constant, so I can take it out of the integral. So then it becomes root 2 x root over 2 minus x plus x square integral 0 to root over 2x minus x square dy by root over x square plus y square. So now if I look at this integral, it is of the form root over dy by root over x square plus y square. So if I substitute y is equal to x tan theta here, then the numerator becomes dy is equal to x sec square theta d theta, and the denominator root over x square plus y square becomes equal to x sec theta. So the integral becomes takes the form of integral sec theta d theta. So integral of sec theta d theta is integral sec theta d theta is nothing but log of tan theta plus sec theta. And how do we get this? We get this by doing this. Sec theta plus tan theta, if I differentiate this, d of sec theta plus tan theta will become sec theta tan theta plus sec square theta into d theta, or sec theta into tan theta plus sec theta d theta. That means d of sec theta plus tan theta over sec theta plus tan theta is equal to sec theta d theta. So if I integrate both sides, the left hand side would give me log of sec theta plus tan theta, which is integral of sec theta. So now therefore we can write this as root 2 x root over 2 minus x plus x square log of, now what is sec theta here? Sec theta is, first we do tan theta. Tan theta is y by x. So log of y by x plus sec theta would be root over 1 plus tan square theta. That means 1 plus y square by x square, which can be written as root 2 x root over 2 minus x plus x square into log of y plus root over x square plus y square over x, and this is from 0 to root over 2x minus x square. So this is from 0 to root over 2x minus x square. So this is equal to root 2 x root over 2 minus x plus x square log of, when y is root over 2x minus x square, then this becomes root over 2x minus x square plus root over 2x over x minus log of, when y is 0, then this becomes 0 and this y becomes 0. So root x square becomes x over x. So log 1 would be 0. So this is the value of this expression. So this can be further reduced to root 2 x root over 2 minus x plus x square log of root over 2 minus x plus root 2 over root x. So this is the final form of this integral, which can be written as root 2 x root over 2 minus x plus x square log of root over 2 minus x plus root 2 minus x square into half log x. So this is the final form of the integral I1. So this is 2I1. So therefore I1 would be half into root 2x root over 2 minus x plus half x square log of root over 2 minus x plus root 2 minus 1/4 x square log x. So this is the final form of the integral that was inside the bracket, or the inside the second integral. So we can see that we have found the value of the first integral, which was inside. So now we will take this and we will try and find out the value of the second integral. So now if we call the whole integral as I, then I is equal to this. So I becomes equal to integral 0 to 2 I1 dx. So which is nothing but integral 0 to 2. I1 has three parts, which is half root 2x root over 2 minus x dx plus half integral 0 to 2 integral 0 to 2 x square log of root over 2 minus x plus root 2 minus 1/4 integral 0 to 2 x square log x dx. We missed out a dx here as well. So we have three integrals now, which is, the first one is this one, I2, which is this integral. The second one is this integral. We call this I3, and this we call as I4. So we have three integrals now, I2, I3 and I4 and we'll solve this one by one. So I1 can be taken as half of I2 plus half of I3 minus 1/4 of I4, where I2 is defined as integral 0 to 2 root 2x root over 2 minus x dx. I3 is defined as integral 0 to 2 x square log of root over 2 minus x plus root 2 dx, and I4 is defined as integral 0 to 2 x square log x dx. So we'll first look at the integral I2. So I2 is integral 0 to 2. We take the root 2 out, this is constant, x root over 2 minus x dx. Now here we can see that there is a square root, so we will substitute 2 minus x with z square. So therefore root over 2 minus x will be z, and dx or minus dx will be equal to 2z dz. So dx is minus 2z dz, and x will be equal to 2 minus z square. So if we do this, then this integral reduces to root 2. We'll forget the limits for now. We'll bring it back to the original x form after we integrate, and then we'll put the limits back again. So let's forget the limits for now. So we'll just do the integral. So this is integral of 2 minus z square into root 2 minus x is z into dx is minus 2z dz, or we can write this as minus 2 root 2 integral of z square into 2 minus z square dz, or this can be written as 2 root 2, and I reverse the sign here, z square into z square minus 2 dz, or this will become 2 root 2 into integral of z4 dz minus 2 integral z square dz. So this becomes a simple integral, and we can do it very quickly. 2 root 2 integral of z4 dz is z5 by 5 minus 2 integral of z square dz is z cube by 3. And now we put back the value of x instead of z. So 2 root 2 into z5 means z is root over 2 minus x. So z5 would be 2 minus x whole to the power 5 by 2. This divided by 5 minus 2 into 2 minus x whole to the power 3 by 2. This divided by 3. And we put back the limits here, that is x running from 0 to 2. So if I put x equal to 0, then 2 minus x will become 0, then the whole term will reduce to 0. And if I put x equal to 2, this term reduces to 0, so the upper limit will be a 0. But if I put x equal to 0, 2 minus x becomes 2, and we'll get values for this one. So 2 root 2 into minus of 2 to the power 5 by 2 whole divided by 5, minus of minus 2 means plus 2 into 2 to the power 3 by 2 whole divided by 3. So this is nothing but I can take 2 to the power 3 by 2 common. So 2 to the power 3 by 2 means 2 root 2. So we have 1 2 root 2 outside, and then we take another 2 root 2 common into 2 by 3 minus 2 to the power 2 by 2 is 1. So 2 by 5, or this can be written as 4 into 2 8 into 2 into 1/3 minus 1/5 means 2 by 15, or this can be written as 32 by 15. So therefore half of I2, because this is half of I2. So half of I2 would be 16. Half of I2 would be 16 by 15. So this is the first term of the integral I1 that we are trying to find out. First term of the integral I1. Now we will go to the integral I3. I3 is equal to 0 to 2 x square log of modulus of root over 2 minus x plus root 2 dx. Now here we can clearly see that there is a log term, so we will substitute root over 2 minus x plus root 2 as e to the power z. So therefore root over 2 minus x becomes e to the power z minus root 2, or squaring both sides we get 2 minus x is equal to e to the power 2z minus 2 root 2 e to the power z plus 2, and I can cancel 2 from both sides, so x becomes 2 root 2 e to the power z minus e to the power 2z. So therefore dx will become 2 root 2 e to the power z minus 2 e to the power 2z dz. So if I substitute all of these values in the integral, I get integral. Again, I'll forget the limits for now. I'll bring it back to the term of x once I do the integration. So integral of x square would be integral of x square would be 2 root 2 e to the power z minus e to the power 2z whole square log of e to the power z means z. Dx is 2 root 2 e to the power z minus 2 e to the power 2z dz. So this is nothing but I can take the 2 common outside the integrals. So 2 integral of z into root 2 e to the power z minus e to the power 2z into 2 root 2 e to the power z minus e to the power 2z whole square dz. Or I can write half I3 is equal to integral of z into, I can take e to the power z common, e to the power z into root 2 minus e to the power z, and from the second term also I can take e to the power z common, so e to the power z square or e to the power 2z it becomes, and we are left with 2 root 2 minus e to the power z whole square dz. So this can be written as integral z e to the power 3z into root 2 minus e to the power z into 2 root 2 minus e to the power z whole square will be 2 root 2 square, which is 8 minus 4 root 2 e to the power z plus e to the power 2z dz, which can be written as integral z e to the power 3z into 8 root 2 minus 4 root 2 e to the power z into root 2, which would be minus 8 e to the power z, and then I have 1 e to the power z into 8 here. So this into this and this into this gives me two terms which have e to the power z, and their coefficients are minus 8. So 2 times minus 8 means minus 16 e to the power z, and then I have root 2 into e to the power 2z, and I also have e to the power z into 4 root 2 e to the power z. So that gives me 4 root 2 e to the power z plus root 2 e to the power z. That means plus 5 root 2 e to the power z, e to the power 2z, and the last term would be e to the power 2z multiplied by e to the power z, which is e to the power 3z with a negative sign. So minus e to the power 3z dz. So this can be written as integral of z e to the power z e to the power 3z into 8 root 2 minus 16 z e to the power 4z plus 5 root 2 e to the power z e to the power 5z minus z e to the power 6z dz. So here we are getting four terms which are of the form z e to the power nz dz, and we have to integrate these four terms in this way. So we know that we have to use integration by parts, where we take z as the differentiable variable and e to the power nz dz as the integrable factor. So we can write this as z and 1 by n e to the power nz. If I integrate e to the power nz dz, we get e to the power nz by n. So this is my first term, and the second term would be integral of e to the power nz by n into dz is 1. So this would be the form of the integral. So that is nothing but z by n e to the power nz minus e to the power nz by n square, or this can be further simplified to into e to the power nz by n into z minus 1 by n. So this is the form of the integral of z e to the power nz dz. So we'll use this for all the four integrals that we'll do right now. So notice the first term is 8 root 2 z e to the power 3z. So this will integrate into 8 root 2 e to the power 3z by 3. E to the power nz will become e to the power nz by n. So e to the power 3z by 3 into z minus 1 by n is 1 by 3. So this is my first term. The second one, minus 16. 16 is the coefficient. So minus 16 z e to the power 4z will become e to the power 4z over 4 into z minus 1 by 4. So this would be my second term. The third term is 5 root 2 e to the power 5z. So this would become plus 5 root 2 e to the power 5z by 5 into z minus 1 by 5. And the last term is minus 1 into e to the power 6z. So minus e to the power 6z by 6 into z minus 1 by 6, which can be written as equal to e to the power 3z into 8 root 2 by 3 into z minus 1 by 3 minus 16 by 4 is 4. So minus 4 e to the power z into z minus 1 by 4, and then I have plus 5 root 2 by 5 is root 2. So root 2 e to the power 2z into z minus 1 by 5 minus e to the power 3z by 6 into z minus 1 by 6. So this is the final form of this integral. Now let's look at the values. We took root over 2 minus x plus root 2 is equal to e to the power z. So when x is equal to 2, e to the power z becomes root 2. E to the power z becomes root 2. And when x is equal to 0, e to the power z becomes 2 root 2. 2 root 2. And what about z? So the value of z is equal to log of root over 2 minus x plus root 2. So when x is 0, z becomes log root 2. Sorry, log 2 root 2, or z is equal to log of 2 to the power 3 by 2, or 3 by 2. Z is 3 by 2 log 2. Now when x is equal to 2, then z becomes equal to log root 2 or half log 2. Half log 2. So these are the two limits within which this particular expression will vary. So we have z is equal to half log 2 as the upper limit and 3 by 2 log 2 as the lower limit, and we have e to the power z is equal to root 2 as the upper limit and 2 root 2 as the lower limit. So we'll put these values in this expression to find the final value of I3. So if we substitute the values now, we will get this as e to the power z is root 2 for the upper limit. So root 2 whole cube into 8 root 2 by 3 into z in the upper limit is half log 2. So half log 2 minus 1/3 minus 4 e to the power z is root 2 into half log 2 minus 1 by 4 plus root 2 e to the power 2z is root 2 whole square into half log 2 minus 1 by 5 minus e to the power 3z is root 2 whole cube by 6 into half log 2 minus 1 by 6. This is the upper limit of the expression, and in the lower limit we'll get minus e to the power 3z would be 2 root 2 whole cube, 2 root 2 whole cube, and then we'll have 8 root 2 by 3 into 3 by 2 log 2, 3 by 2 log 2 minus 1/3 minus 4 e to the power z would be 4 into 2 root 2 into z minus 1 by 4. So 3 by 2 log 2 minus 1 by 4, and then I have root 2 e to the power 2z. So plus root 2 e to the power 2z would be 2 root 2 whole square into 3 by 2 log 2 minus 1 by 5, and then I have minus e to the power 3z would be 2 root 2 whole cube divided by 6 into 3 by 2 log 2 minus 1 by 6. So this is the final form of the integral, and we just have to simplify it now. So let's see how we do that. So this can be written as root 2 whole cube will be 2 root 2, and then I collect the log 2 terms in the first bracket. So for log 2 we have 8 root 2 by 3 into half, which is 4 root 2 by 3. So 4 root 2 by 3, and then I have half and 4 root 2, so minus 2 root 2, minus 2 root 2, and then I have 2 root 2 whole square by 2, which is plus root 2, plus root 2, and then I have root 2 whole cube is 2 root 2 divided by 2, so root 2 by 6, so minus root 2 by 6. This into log 2, and then I collect the constant terms. So I have 8 root 2 by 3 into minus 1/3, so minus 8 root 2 by 9, 8 root 2 by 9, and then I have 4 root 2 into minus 1/4 with the negative sign in front, so that becomes plus 4 root 2 into 1 by 4 becomes root 2, and then I have 2 root 2 into minus 1 by 5, so minus 2 root 2 over 5, and then I have plus 2 root 2 divided by 6 into 6, so 2 root 2 by 36. So this would be my first term, and the second term would be 2 root 2 whole cube will be 16 root 2 into, I collect the log 2 terms in the second bracket, so log 2 into 8 root 2 by 3 into 3 by 2 would be 4 root 2, 4 root 2, and then I have 4 into 2, 8 root 2 into 3 by 2, which is 4 root 2 into 3, 12 root 2 plus 12 root 2, and then I have 2 root 2 whole square, which is 8 root 2 into 3 by 2, so 4 root 2 into 3, 12 root 2. So this was a minus sign, and the next one would be 12 root 2 with a positive sign, and then finally we have 2 root 2 whole cube, which is 16 root 2 into 3 by 2 by 6, so minus 16 root 2 by 6 into 3 by 2, so we simplify this, becomes 3, and then 2 and 2 4 is 4 root 2, and then I have a 3 here, so I cancel this, so minus 4 root 2. So we see that here I get a minus 12 root 2 and a plus 12 root 2 and a 4 root 2 and a minus 4 root 2, so all cancels out, log 2, and I get the constant terms now, so 8 root 2 by 3 into minus 1/3, so minus 8 root 2 over 9, 8 root 2 over 9, and then I have minus 8 root 2 into minus 1/4, so plus 8 root 2 over 4 becomes 2 root 2, and then I have 2 root 2 whole square is 8 root 2 into minus 1 by 5, so minus 8 root 2 by 5, and then finally I have 2 root 2 whole cube, which is 16 root 2 by 6 into 1 by 6, so plus 16 root 2 into 1 by 36, so this simplifies to 4 root 2 by 9, 4 root 2 by 9. So this is where we are. So we'll simplify this a little bit, so this becomes 1 by 18, and yeah, so finally we get this form of the expression. So this becomes 2 root 2 into, I take the denominator as 6, so 4 root 2 into 2 would be 8 root 2, and minus 2 root 2 plus root 2 is minus root 2 into 6, so minus 6 root 2, and I have one more minus root 2 into log 2, and then I have a 18, I have a 5 and a 9, so I take 18 into 5 or 90 as the denominator, so plus 90 as the denominator, so 8 root 2 into 10, so it will be minus 80 root 2 plus root 2 minus plus root 2 into 90 is plus 90 root 2, and here I have minus 18 into 2 would be minus 36 root 2, and then plus 5 root 2. So this is the first bracket, and then minus 16 root 2. There is all the terms here have cancelled out, so log 2 has no coefficient, so we only have the constant terms. So here we have 9 and 5, so we take 45 as the denominator, and I have minus 8 root 2 into 5, which is minus 40 root 2, and then I have 2 root 2 into 45, so plus 90 root 2, and then minus 8 root 2 into 9, so minus 72 root 2, and then finally I have 4 root 2 into 5, so plus 20 root 2. So if I simplify this, this becomes equal to 2 root 2 into 8 minus 6 minus 1. So 8 minus 7 is 1, so root 2 over 6 log 2 plus 90 minus 8 is 10, 10 and 5, 15 minus 36. 15 minus 36 is minus 21. So minus 21 root 2 over 19, which is 7 root 2 by 30. 7 root 2 by 30. And then I have minus 16 root 2 into 90 minus 40 is 50. 50 plus 20 is 70, minus 72 is minus 2 root 2 over 45. So this becomes equal to 2 root 2 into root 2 is 2 into 2, 4 by 6 is 2 by 3 log 2 minus 7 root 2 into 2 root 2 is 14 into 2, 28 minus 28 over 30, and then I have plus 16 root 2 into 2 root 2 is 32 into 2 is 64. 32 into 2 64 over 45. 64 over 45. So this is 2 by 3 log 2 plus I have 45 and 30, so I have to take 90 here. So minus 28 into 3 is minus 84 and plus 128. So this is where we stand. So this can be finally written in the form 2 by 3 log 2 plus 44 by 90 or 22 by 45. So 2/3 log 2 plus 22 by 45. This is the final value of this integral. So now we have got the value of two integrals, namely I2 and I3, and we'll go in for the last integral, I4. So I4 is integral 0 to 2 x square log x dx. again we'll follow the same rule. We will substitute, because we have a log x, so we'll substitute x as e to the power z. So log x will become z, and x square will be e to the power 2z, and dx will be e to the power z dz. So this will become, we'll forget the limits for now, we'll bring it back to the original form after we integrate. So x squared will be e to the power 2z, log x is z, and dx is e to the power z dz. So this is a very simple form. We just did this form in calculating the value of I3. So this is z e to the power 3z dz, that is nothing but e to the power 3z by 3 into z minus 1 by 3. So this is the form of the expression that we get. So now if I substitute the value of z in this, I will get e to the power 3z would become x cubed by 3, and z is log x minus 1/3. So this will become 0 to 2 range. So this will become equal to, for x equal to 2, this would be 8 by 3 log 2 minus 1/3, and for x equal to 0 this becomes 0. So this is 8 by 3 log 2 minus 1/3. So 1/4 of I4 will be equal to 2 by 3 log 2 minus 1 by 3. So this is the value of 1/4 I4 which we need as the last term. 1/4 I4, this is what we need as the last term. So now let's put all the terms together and find the value. So the integral I is the summation of these three. So half I2 is 16 by 15 plus half I3 is plus 2 by 3 log 2 plus 22 by 45, and minus 1/4 I4 is minus 2 by 3 log 2 minus 1 by 3. So this becomes minus 2 by 3 log 2 plus 2 by 3 log 2 would cancel out, and this becomes 16 by 15 plus 22 by 45 plus 2 by 9. So I have 15, 45 and 9. So I'll take 45 as a common denominator. So 45, and I have 16 into 3 is 48, and then plus 22, and then 9 into 5 is 45, so 2 into 5 is 10. So this becomes 80 by 45, or if I cancel by 5 it becomes 16 over 9. So you see the option B, 16 over 9 is the correct answer.